probability distribution function, probability distribution function of continuous random variable. Okay, this is 4.6. Now, by definition, probability, just now is probability function, this is a probability distribution function. So by definition, the probability distribution function of continuous, this you can refer to page 80. So by definition, fx is a probability function is equal to, we need to integrate from negative infinity to x, fx dx. This is the lower limit, the lower limit. Okay, so now the definition here is for f negative infinity, this is equal to 1, and b f positive infinity, sorry, this is equal to 0, this is equal to 1, and then if I have p less than q, then fp is less than fq. Now let's say I have this function. I have a function here. Let's say I have a simple function here. Let's say I have a function here. Example 4.13. Example 4.13. I have a example here is my fx here is equal to x plus 3, 0, x is less than 0, x is greater than 0, x is greater than 0, 0 as well. I want to find the probability distribution function, probability distribution function. So my probability distribution by definition is fx is equal to negative infinity to x, fx dx. This is by definition. Okay? So we know that this part, meaning to say your lower limit here, your x here is from x is from 0 to infinity. The lower limit here is 0. So to find fx by definition, we use this definition. So to find capital Fx, so you just substitute. So your lower limit there is, instead of negative infinity, our lower limit here is 0. Then we need to put here x remain here x. So, and the function is x plus 3 dx. Then if you integrate here, you get x raised 2 over 2 plus by 3x, substitute for 0 and x, I will have the answer here is x raised 2 over 2 plus by 3x. This is my probability density function, and then we can put here our limit here is x is greater than 0, this x is greater than 0, 0 elsewhere. And this is how we write the probability density function for the given function above there. Okay. Okay, the next part is I want to show you how to solve, the new part here is the conditional probability of continuous random variable. So for the continuous probability, joint probability function 4.7, page 82, the conditional probability function of continuous random variable. So by definition, okay, by definition, the conditional property is that if I have, it's not a condition, it's a, sorry, it's not a condition, it's a joint property function. Joint property function of continuous random variables, right? So by definition, if we have a function, we have two variables. Joint means two variables. We have fxy. These are property functions. So if I want to find the joint property here, so by definition, the joint property here is fxy must be greater than 0. Must be greater than 0. Then the integration of double integration, because we have two variables here, x and y, we need to have two double integration, which is negative 0, negative infinity to infinity, and also from negative infinity to infinity, fxy dx dy, this must equal to 1. Okay, must equal to 1. This is what I call the joint. Because of the joint here mean you have two variables, x and y. Okay? That's why we call joint property function. And then